Hi, my name is Srinivas Angara and I would like to talk about building service choreography applications using BPEL. There's always a strategy that drives business transformation. The strategy can arise out of enterprise modernization, new solutions being brought on board, and many other reasons. At the top level, we have business leaders, business architects, enterprise architects formulating a strategy based on a future state vision. They work together to build a roadmap to achieve that vision. As part of that roadmap, they identify services and solutions that need to be built. Then, it is the responsibility of the enterprise architecture team to build high-level artifacts. These are then given to the application delivery teams, who in turn are responsible to develop and implement these solutions in a production environment. You could say that this is TOGAF in a nutshell, where the enterprise architecture team is driving the process. This is a top-down approach, where a business strategy or vision defines what solutions are prioritized and built. Having defined this top-down approach, which is nothing new, I now want to identify a problem and then propose a solution. On many engagements, I've seen enterprise architects, business architects, and solution architects build design documents and other artifacts. These artifacts are then given to the application delivery teams to implement these solutions. The fact that solution architects depend on these artifacts for the accuracy of the implementation creates this communication gap. There is a way to minimize the creation of these design artifacts. If we can do that, then we can take our agile development methodology to a whole new level. This is the purpose of this presentation. Before I do that, I would like to take a moment to position service choreography within the context of SOA reference architecture. Sometimes these applications are also called composite applications. As a sample, I would like to use a classic claim processing service within the healthcare industry as a sample choreography application. Here we have three different vertical applications: eligibility, claims, and contract management. Eligibility provides verification services. Claims provide services to accept new claims and return the status of current claims. Contract management provides general terms and conditions. These applications provide services that are designed by solution architects. Development engineers take direction from solution architects and implement these services. We want to implement a simple process that receives a claim and validates it. There are no human tasks in this process. Since there are no human tasks, you can also refer to it as straight-through processing. Straight-through processing is a major topic within SOA space. Within IBM software stack, there are 4 different products that can claim to implement straight-through processing. One of the differentiating factors is whether or not you have human tasks within your process. If you have human tasks within your process, then that process is based on BPEL standard. The focus of this presentation is service orchestration without human tasks. For that reason, we are focusing on IBM Business Process Manager Advanced. WebSphere ESB and IBM Integration Bus are runtime engines to implement mediations and message flows. They're primarily used to transform data on the wire. BPEL, on the other hand, is more like a programming language. You can declare variables, create flow of control structures such as if, then, else, and loops. You can add event handlers and exception handlers. Also, and finally, you can create both micro and macro flows. Since it's more like a programming language, you can use it to implement composite applications. Now that we got all the technical details and terminology squared away, I want to take you into a different world. Building a service or a solution is like painting a landscape on a canvas. Yes, building a service or a solution is like painting a landscape on a canvas. Let's take a look at the different steps. The first step is to draw the outline. The second step is to draw the shadows. Then add some greenery and finally complete the finer details. If you have defined this as a process, then different people can work in different areas on the same canvas. Yes, if we define this as a process, then different people can work on different areas on the same canvas. Using this as an analogy, we can build solutions where solution architects and development engineers are working on the same project artifacts while building a solution. This is important. When everyone is working off the same project artifacts, you can eliminate the communication gaps and take your agile development methodology to a whole new level. This is important. When everyone, solution architects and development engineers, are working on the same project artifacts within the development tool, then you can eliminate the communication gaps and take your agile development methodology to a whole new level. So let's take a look at our simple process, simple health insurance claim process. When a claim comes through the door, we want to validate the data, check for eligibility. We want to claim price all the procedures that have been performed, and add that claim to a claim repository for further processing. First, we need to define interfaces and canonical data models. Interface is an entry point into the process. Data objects carry data. It is a function of the enterprise architecture team to standardize and publish these artifacts. On many engagements, I've seen that developers are responsible for the canonical data models. I personally believe that this is a bad practice, and they need to be standardized by the enterprise architecture team. This is the first step in building the process. Here we're defining an entry point into our claims process. It shows different services that this process calls upon. To assemble this diagram, you don't need deep technical skills. A solution architect can easily assemble this diagram very easily. This is the first step in building our claims process. Here we are defining an entry point into our process. It also shows different services that this process calls upon. To assemble this diagram, you don't need deep technical skills. A solution architect can easily assemble this diagram. This is like the outline of our landscape picture. Now we're getting deeper and building a high-level process. All you need is basic flowcharting skills to build this diagram. At this point, we have built a basic outline of our process. This is the next step of our landscape picture. It is a good idea to build some best practices and patterns to assemble a flow like this. Up until now, we have solution architect working with the tool to build a high-level process. There are no implementation details. have been added up until this point. And that's where our step 3 comes in. In the next step, we start adding implementation details. We can focus on specific areas of the process. Further details about process are worked by both solution architect and development engineer. Here we see actual links being established to external services. In the final step, error handling is added to the process. This is purely the domain of the application delivery teams. For simplicity, I'm pointing out error handling. However, development teams add plenty of details like logging and tracking information. These are technical implementation patterns. After this point, the next steps are pretty much testing and preparing for releasing the solution. In this 4-step process, solution architects and development engineers are working on the same project artifacts. This is important. They're working on the same tool and the same project artifacts, and this eliminates the communication gaps. The main benefit is we want enterprise architecture team have complete control on the design. We want to be able to decouple solution design and application delivery. At the same time, we want to maintain strong cohesion between architecture and applications. 90% of the application development work is in issue resolution and incremental changes. We want our solution architects to drive these changes. We want our solution architects to be on top of these changes. I'm just taking a classic example from Apple, where their products are designed in California and implemented and manufactured in China. In software development too, our industry is changing quite a bit, where we want to maintain the design aspects in-house, and most of the software development work is offshored. So we can think like Apple and build our solutions like Apple. So the other side of the benefits, when solution architects and development engineers are working on the same tool and on the same project artifacts, even though they're working in the tool and on the same projects, on the project artifacts, their focus is completely different. Solution architects are primarily focused on the functional side of the solution. They're building solutions prioritized by the business strategy. They're able to react to changing market conditions. Development engineers, on the other hand, have a razor-sharp focus on the technical side of the solution. They're working on best practices, building patterns, and that could be repeated, and that makes them more productive. One drawback about this on many engagements that I've seen is that the solution architects need to have this tool. They need to be able to access the project artifacts. And for this reason, they need a license for the product, and they also need some training. And this means cost. This is the main drawback. So there is a cost associated with licensing the tool and some training for the solution architects. However, I believe that the cost justifies the productivity gains. Well, thank you very much. I hope you found this presentation interesting. I appreciate your feedback. Please feel free to send me an email at srinivas.angara@gmail.com. Thank you very much, and have a nice day.